Hello, Math B Honors students. Today we'll be working on the 3.1b lesson on standard form. So the previous lesson was on slope-intercept form, y equals mx plus b. And now we will be learning about a new form, which is called standard form. Okay, so let's go ahead and read this paragraph. When traveling in space, each astronaut is allowed to take a care package. Items must meet the written guidelines to ensure safety. The weight limit of a care package is 11 pounds. Go ahead and underline that. If you are an astronaut and have decided to take candy bars and granola bars as your snacks, how many are you allowed to take? Each granola bar weighs 6 ounces, and each candy bar weighs 2 ounces. So you can already tell that there is going to be a trade-off between granola bars and candy bars. You can't really take unlimited amounts. Remember that you can only take 11 pounds. And it's important to realize that 1 pound is equal to 16 ounces, which we're going to talk about later. Okay, so let's go ahead and just complete the table below. So if we had 0 candy bars, obviously we would have, 0 times 2, which is equal to 0. And because it's 2 ounces for each candy bar, each granola bar weighs 6 ounces. And you would say, okay, 0 granola bars times 6. I know this is kind of obvious, but it's 0, right? And you can see the work shown here as well. Here, 10 candy bars, and for each candy bar weighing 2 ounces, would really mean 20 total ounces, right? 10 granola bars, when each granola bar is worth 6, is really 10 times 6, which is 60 total ounces, right? And I'm going to show my work by doing 2 times 10 plus 6. 6 times 10. And that gives me a grand total of 80, right? You can see that's well below the 11 pound maximum, okay? Now, how many candy bars would weigh 8 ounces? Well, each candy bar is 2, so we kind of know that this is 4, right? You take the total weight and divide it by 2. You take this total granola bar weight and you divide it by 6, and you kind of know that you have 4 granola bars if the total weight is 24. Right, 2 times 4 plus 6 times 4 is still well below my maximum of weight. And that's going to be 8 plus 24, which is 32. Okay, let's go ahead and read A. So if X represents the number of candy bars and Y represents the number of granola bars, write an equation that models the relationship between the weight of candy bars, the weight of granola bars, and the total weight of the snacks. Okay, so this is kind of what standard form is all about, right? Standard form is when you have 2 different variables on the same side. You can see that a candy bar weighs 2 ounces, and X is going to represent the amount of candy bars I bring, or this astronaut brings. And then you have granola bars as your Y, which we know that 6 ounces is going to equal the total weight for 1 granola bar. And you kind of want to say that this is equal to the total weight, right? You see how both the variables are on the same side here. Name the coefficient of X in your equation and explain what it represents. So it's kind of asking, like, what does this 2 represent? And you can see on the bottom line, it also says, what does the 6 represent, right? So the 2, and it represents the weight of each candy bar. Obviously, the 6 represents the weight of each granola bar, right? Now, we could do this with many other examples. You can see how items at the store would have costs, and you can use the same kind of standard form understanding to create an equation there of each granola bar. Okay. You can also start to notice that there is a trade-off, right? You can see how these are direct factors of one another, and obviously, there's a certain amount of candy bars that weigh the same amount as a granola bar, and there's a trade-off between the two. Okay. Okay, so now I know it says 11 pounds in the care package, but right now we're going to change this a little bit and just say that there's a 6-pound maximum. Remember that 1 pound is equal to 16 ounces. So really 6 times 16 is the maximum number of ounces you can bring. And you can see that that's going to be 96 ounces max, right? That's the most you can bring. Okay. So let's go ahead and discuss some examples of possible combinations that you would bring. Okay, so the first one, let's just do Mr. Quo. And Mr. Quo is he's a health freak. He absolutely does not eat candy at all, never. So I would never bring candy bars to space. And my total weight for the candy bars would be 0. And that means I would bring a maximum amount of granola bars, right? So I kind of know that if each granola bar weighs 6, I can actually bring 16 granola bars, coincidentally, right? I can bring 16 granola bars because 6 times 16 is exactly 96. So my total weight here is 96. This is actually, there's a fancy way to say this, but you can see how all I have is the y variable, and I don't have the any x variable. Does anyone know what that's called? Okay, well, I'll write it later in a few minutes. Okay, let's have some fun with this. So obviously we know that there's a trade-off, and you can see that 3 candy bars is really the equivalent of 1 granola bar in weight. So if I were to drop this, or I'm sorry, increase the candy bars by 3, you kind of know that all I have to do is drop my granola bars by 1, right? So I can say I want 3 candy bars, which gives me a total weight of 3 times 2, which is 6 ounces. And that's really the equivalent of 1 granola bar, isn't it? Right? 6 times 15 is going to give me 90. And I still have a total of 96 total ounces because I understand the trade-off between candy bars and granola bars. If my candy bars continue to increase, obviously my granola bars have to decrease, right? You can't just keep adding more and more because there's a maximum, right? So I'm going to keep doing this. Let's do a 6. We know that 6 times 2 is going to equal 12. And because I have 6 candy bars, I have to continue to drop off my granola bars by 1. And I get 6 times 14. 6 times 14 is actually 60 plus 24, which is 84. And 84 plus 12 still gives me 96. Okay, let's do a final one. Let's have fun with this. Let's say I want to have 12 candy bars. Then I do 12 times 2, which is 24. And you kind of have to think, okay, well, 6 candy bars mean I took away 2 granola bars. 12 candy bars means I have to take away 4 granola bars from my maximum. And really, that just means that I have 12 granola bars. 6 times 12 is going to equal 72, right? And 72 plus 94 is indeed 96. Now, what's interesting is, I can't believe I forgot to do this and probably should do one more, but let's say I wanted all candy bars, right? How many candy bars can I bring if I want all candy bars with no granola bars? Well, if you said 48, you're correct, right? 48 times 2 is indeed 96. And then I would have 0 granola bars, which is 0. And then I would have 96, right? Okay, so the point of this was to show that let's go ahead and write the fact that this has a 0 of x, which means this is what we call the y-intercept. The y-intercept, by definition, class, is when you have a 0 value for your x. This is the y-intercept, right? Similarly, if you understand that, then when you have 0 for y and you have all of it on the x, what do you think that will be called? Right? That's called the x-intercept, right? The maximum amount of x's you can have with no y. So it's important to identify both of these. And go ahead and just write 2x over here and 4y because, oh, I'm sorry, 2x and 6y. I'm sorry, not 4y. Where did I get the 4? 6y, and you realize that that has to equal 96, right? And essentially, this bottom row, this last row on the table, is our equation in standard form. 2x plus 6y is going to equal 96. Now, what do we notice about standard form, class? Well, we know that x and y are on the same side. We also know that x is alphabetically before y. And last, we kind of know that this equation or this form is most likely used when we have like a budget, a maximum, and we have two different items that we want to buy, right? So just keep that in mind as we continue on with this question, right? So yeah, have this table ready because the next few questions will involve the table. What is the maximum number of candy bars you can pack? Write the value as an ordered pair. If graphed, what would this value be called? So we kind of talked about that already, right? What is the maximum number of candy bars? The maximum number of candy bars is 48, 0, right? So you would say the maximum number of candy bars I can bring is 48. And this is known because the candy bars were defined as x, this is known as the x-intercept. When you have all values for x and the y value is 0. What is the maximum number of granola bars? Write this value as an ordered pair. If graphed, what would this value be called? Okay, so looking at our table, we know that the trade-off is 3-1. So if I have 48 candy bars, I can take all of them away and I can bring 16 granola bars. The maximum value here is max value amount is 16 granola bars, right? And you would realize that this, we talked about this all last module, but this is the y-intercept, right? The y-intercept by definition is when your x value, the point where it crosses the y-axis, and it's where your x value is 0, right? So it's kind of like the opposite of the x-intercept. Okay, now let's go ahead and graph. Okay, this is going to really bring home the concept. When we graph, notice how the axes of my graph is labeled. Number of granola bars is on the y because that's the y-axis. The number of candy bars is the x-axis, and it's obviously 48 for our maximum. So one of the easier ways, hopefully you can find, is remember that our equation was 2x plus 6y is equal to 96. Well, one solid thing about standard form is you could immediately kind of identify the maximum amount of one variable you can have and then kind of do it the opposite way, right? So 2x plus 6y equals 96. If I didn't want any of the y granola bars, I can kind of block it and say 2x is equal to 96. And that actually ends up being 48. So it's quite obvious that 48 is my x-intercept. If I want to know the y-intercept, all I have to do is block the x variable and solve for the y, right? 6y equals 96. That means 96 divided by 6 is going to be 16, right? You can see how that my y-intercept is clean, my x-intercept is clean. And once you have both your intercepts graphed, or plotted, I should say, all you have to do is connect the two intercepts, and you now have the equation graphed. You have the line of this equation correctly graphed. You could see the trade-off, right? Now, it's not really clean, perfectly clean on distinct points because the trade-off is 3-to-1. If it was an even number, it probably would look very clean with the distinct points, but use the x and y intercepts graph. I'll make it super clear. 0, 16 is right here. 48, 0 is right there. And anything in between is a combination that would satisfy the equation. What do you observe from the graph? I think one of the most important things you would say is, do we all realize that the graph is negative? It has a negative slope, right? So let's go ahead and write that. Why does it have a negative slope? Well, it's because the negative slope is representative of the trade-off between the x and the y variable, right? The line is negative because there is a trade-off, because of the trade-off between candy bars and granola bars, right? And quite literally, for us to write it in a math way, you would say, as x increases, y decreases, and vice versa, right? As you increase the number of candy bars you want, your granola bars have to decrease. There's a trade-off between the two, right? And that's why there is a negative slope. Okay, almost done here. Let's wrap it up. Linear equations can be written in slope-intercept form, y equals mx plus b, where m represents the slope and b represents the y-intercept. Linear equations can also be written in standard form, which we just talked about. The standard form of a linear equation is ax plus by equals c, where a, b, and c are integers. Please underline that, circle that. A, b, and c values all have to be integers. A and b are not 0, and a is positive. Okay. In this general form, the variable terms on the left side of the equation are on the left side of the equation, and the constant term is always on the right side of the equation, right? Okay, so let's go ahead and convert. Convert the standard form equation 2x plus 6y equals 96 to slope-intercept form. Okay, so let's do that. This is hopefully a simple process for you. You know that our goal for slope-intercept form is y equals mx plus b, essentially saying isolate your y variable. So as you get used to this, you'll realize you've been doing it for a while now. You just simply subtract both sides by the x. You get negative 2x on both sides. Notice how I put the negative 2x in the front, because that's what slope-intercept form is. Then I divide both sides by 6, and I get y is equal to negative 1/3 x plus 16. Okay. So examine your graph of 2x plus 6y equals 96. Does the graph show the same slope and the y-intercept as stated above? Well, obviously, it does show the 16 as your y-intercept. But more importantly, it also doesn't it show the slope? Technically, class, isn't this negative 16 rise for a run of 48? And if that's a negative 16 rise, and then a run of 48, doesn't that actually mean the rise is negative 16, the run is 48, which represents negative 1/3 as your slope, right? So in fact, yes, it does. It shows negative 1/3 as a slope, and it shows 16 as a y-intercept. I hope you realized from this video clip that standard form is just another version of an equation of a line. And you can always flip between slope-intercept form and convert it to standard form, which we'll be doing in the next video. Thanks for watching.